All right, let's break down one of the most fundamental ideas that makes our digital world, well, work. We're talking about serialization and deserialization. It's basically the secret language that lets all of our favorite apps and services talk to each other. Let's get right into it.
So, have you ever really stopped to think about this? The app on your phone is probably built with something like JavaScript, but the server it needs to talk to, that could be running on Rust or Python or Java, a completely different language. How in the world do they understand each other? It seems like it should be impossible, right? Well, that's the exact problem we're going to solve today.
And really, what we're looking at is a modern-day digital Tower of Babel. You've got all these different applications, all these different servers, each one speaking its own unique programming language, with its own rules for how to structure data. Without some kind of translator, it would just be complete chaos. And this right here really gets to the heart of the problem. On the left, you've got this kind of loosey-goosey JavaScript object. It's flexible, it's dynamic. Then on the right, you have a super strict Rust struct. It's compiled, it's rigid, it knows exactly what its data types are. They're just fundamentally different. Trying to send one directly to the other, it's like that old saying, a square peg in a round hole. It's not going to work. It just ends up as total gibberish. So, okay, if they can't talk directly to each other, they need a middleman. Or, even better, they need to agree on a common language they can both speak. And that brings us to the absolute need for a standard.
And the solution, honestly, is kind of genius in its simplicity. Both the client and the server just agreed to use a shared middle-of-the-road format. You can think of it like a universal translator or a neutral meeting ground. Before the client sends anything, it translates its own data into this shared language. And when the server gets it, it knows exactly how to translate it back out of that shared language and into its own native tongue. Problem solved.
And this whole two-way translation process, yeah, it's got a name. In the engineering world, we call it serialization and deserialization.
So first up, we've got serialization. Think of this as the sending part of the journey. This is the process of taking your app's internal data, like that JavaScript object, and converting it, or serializing it, into that standard format, ready to be sent across the internet.
And then, of course, you've got the other side of the coin, deserialization. This is the receiving part. It's what happens when that data arrives. The server takes that standard format and deserializes it, turning it back into a native structure it can actually use, like that Rust struct we were talking about. Okay, so this slide just lays it all out, the entire round trip. You start with a JavaScript object on the client, it gets serialized into the standard format, it travels across the network, then, on the other side, it gets deserialized back into a perfect, ready-to-use Rust struct. It's a beautiful, seamless journey.
So what is this magical standard format we keep talking about? Well, for most of the web you use every day, the answer is JSON. It is the true lingua franca, the common language of the internet.
I mean, look at this. Sure, there are other formats out there. You might see the older XML or maybe a super efficient binary format like protobuf, but JSON is just the king. We're talking 80% of the time, it's the language of choice for the APIs that power pretty much everything you do online.
So what does this stuff actually look like? Well, the name, JavaScript Object Notation, kind of gives the whole game away, right? It looks almost exactly like a regular JavaScript object. And that's a huge reason it got so popular. It was just a natural fit for web browsers. Plus, and this is a big deal, it is super easy for humans to read. You can just look at it and instantly understand what's going on with the data.
And the best part? The rules are so simple. It all happens inside a pair of curly braces. All your data is organized in key-value pairs. The keys always have to be strings with double quotes around them. And the values? They can be simple things like a string, a number, a boolean, or more complex stuff like an array or even another whole JSON object inside. That's really it.
Okay, theory's great, but let's put it all together and walk through the anatomy of a real-world request to see how this all plays out. So in this case, our client wants to add a new book to a database. It takes all the info about the book, serializes it into this nice, clean JSON payload you see here, and sends it off in a POST request to the server's book API. Now, the server gets that message, it deserializes the JSON back into a format it can work with, adds the book to the database, and then it's got a reply, right? So it grabs the whole updated list of books, serializes that into a new JSON string, this time it's an array of objects, and sends it right back to the client. The loop is complete.
And this is the big takeaway, especially if you're an engineer. This is your world. You live and breathe at this layer of communication. You send JSON, you receive JSON. All the super complicated stuff happening underneath, the network protocols, the data packets, the raw bits and bytes flying around, you don't have to worry about it. It's all an abstraction. Your job is just to make sure the JSON you send makes sense and to understand the JSON you get back.
And that brings us to a final, really interesting thought. For years, JSON has been the rock-solid, dependable common language of the web. But technology never, ever stands still, does it? So it really makes you wonder, what's next? What will be the next universal language that all of our applications learn how to speak?